Welcome to this video. Today I will show you how to analyze bone defects using the Emalytics preclinical software. I will open the software first, and you can find an example dataset under Tutorials, CT, Bone Defect, Load Example Dataset. And what we have here is the left rat hip, and a piece of this left hip of the rat was cut out or removed to use it as material for bone remodeling. And this one is the scan after surgery, and we also have the one scan before surgery as overlay. Let me adjust the windowing a little bit. Like this. That looks nice, okay. And you see that it's a scan before surgery, so there's still the left hip complete. And now the scans are in a different position, and we can use the marker-based fusion to align them. I'm not gonna explain the image fusion here in detail because there's another tutorial about it. You can find it under Tutorials, General Image Fusion. So if you have questions about the image fusion, watch this video. I will perform some marker-based image fusion, and therefore I will hide the overlay. Focus on the underlay first. I will create some markers using the marker menu of the mouse action toolbar. You can find it on the left side here. I will use this hole, this small hole in the bone. Let me tick auto name markers, then it's faster. Here's also another hole. I will use it, as well as the arc here, and also here. Okay, now I placed 4 markers, and make sure that the markers are not aligned, because then the fusion will not work. So now I have to go to the overlay and place the markers on the same position in the same order, but I have to change the rendering of the overlay to the ISO rendering, because you cannot place markers on the volume rendering. I will rotate it a little bit, that it's in a similar position. And now I will try to place the same markers at the same position. Like this. And now we can go to Fusion, which is the overlay to underlay, computation, translation, markers. And now they're a bit aligned. Yes. And now I'd like to segment the region of the bone that was removed. And therefore I will add a class temp. Perform a thresholding above on the underlay, above 2000. Let me show it to you. Now I will segment the left hip, create a class left hip first, and perform a fill region operation. You can also find it here in the mouse mode. And now I have the left hip segmented. I will save this one as left hip. And let me delete the temp class and dilate this a little bit to make it thicker. Morphologic, dilate 10. And now I will perform a fusion based on the left hip. And this is a nice trick, because as you see that the blacks, they are always in a different position, so they are not really reliable, but the hip is always in a similar position. And when I restrict my fusion now to this part, it's more reliable and more accurate. Which is the overlay to underlay, computation, translation, image-based course. Now it's computing. And you see now that it's a little bit better aligned. At least the hip part of it. Okay. And we can also do a fine fusion So overlay to underlay, computation, translation, image based, fine. To make it even more accurate. Now we will delete the left hip because we don't need it anymore. And by the way, let me change the 3D rendering back to a volume rendering. Okay. And now we want to segment the missing bone or the bone that was removed, and therefore we will add a class temp. Perform a thresholding again on the overlay this time above 2000. And you see that also the missing part was segmented as temp. And now I will load a single class under File Segmentation, load single class from the left hip. Override all classes. And when I jump here, let me hide the overlay. In green you can see that this part is the removed bone or the missing bone, and it was segmented because we kind of subtracted the odd left hip. And we can now dilate the hip. So go to left hip, perform a morphologic dilation with 1. Then let me add a class piece and perform a fill region again. I will change the color that you can see it a little bit better of this piece. Go to yellow. And now you nicely see that we have this missing part or missing bone segmented. And we can delete the other classes because we don't need them. The temp class and the left hip. And yeah, see, we can investigate it a little bit in 3D. And what you can do now, you can check out some statistics under statistics, class statistics selected layer of the underlay. And you can see the volume of this piece and also some other parameters. And with the 3D printing menu, you can send the segmentation as an STS. You can save it as an STL file, and then you can send it to a 3D printer to print it out, this missing piece. And yeah, in this way you can segment bone defects. I hope this helps. Thanks, bye bye.